everyone, I'm Rishi from Smart Interviews. Welcome to our YouTube channel. Let's start with the first problem of starters 134. Okay, it's a very simple problem. That is, you have been given two values, x and y. X is the initial amount that you have in your bank. Okay, and y is the number of years. Okay, y is the number of years, and x is the initial amount. Now, what you have to do is basically they have said every year you can make a choice. That is, you can increment your value x by 1000. Okay, you can increment, that is your x will become either x plus 1000, or you can double your value x, that is basically x will become 2 into x. Now every year you can make one of this choice. Every year you can make one of this choice. Now each and every year you have to make one choice out of these two. After y number of years, what is the maximum amount that you will be achieving? This is what you need to answer. Okay, now for this problem, let's directly jump into the logic because it is a easy one. What you'll do, you'll simply say while y minus minus. Every time you can go for something like, if like x into 2 is greater than x plus 1000. Okay, you will simply increment it by x into 2. If not, you will simply say x plus 1000. Okay, this is a very simple way of writing the code. Okay, I'm going to show you a different way of writing the same thing. How do we go for this? If you see, out of these two options, that is incrementing x by x plus 1000 and doubling your values, out of these two options, when you want to go for this and when you want to go for this, if you see in here, let me take a simple value, something like 1000. If I take something like 1000, okay, or let's say 1000, okay, in here, if I increment it by 1000, okay, I'm assuming this is my initial amount. If I increment it by 1000, what will be the overall value that I'll be getting? It will be something like 2000. Okay, but for this same initial amount, if I go for doubling it, if I go for doubling it, doubling is basically into 2 of this, which will be 2000. Now which of this is larger? Obviously, after doubling it, we are getting the larger value. Okay, so that means any value, any initial value which is greater than or equal to 1000, okay, doubling will be the best choice. Doubling will be the best choice. Now what is the choice that like what is the point where you'll make this choice? Obviously, if x is greater than or equal to 1000, if you are going for this, okay, maybe when x is less than 1000, you might be going for this. Let's just check for it. Okay, so let's say we have something like 500 or something. Okay, when you have your initial amount as 500, adding 1000 to this will is going to give you 1500, whereas doubling this is going to give you 1000. So you'll go for adding 1000 to it. So I hope you were able to understand what I'm saying. So that is, um, yeah, let's go for writing the code. Nothing much. Okay, give me 1 second. Huh. So if x is greater than or equal to 1000, if x is greater than or equal to 1000, in this case, tell me what are we trying to do? We are just doubling. Always we can go for doubling it. Okay. Now, how many times will we double? Let's say y is something like 3. Okay. You'll double your x 3 times. Okay. Whatever may be the value of y, you need to double it those many times. So basically, your if y is 3, your x will be multiplied with 2 into 2 into 2. Okay, 3 times. Okay, it is nothing but simply multiplying your x by some 2 power y times. Okay, 2 power y times. Now you'll make this choice if x is greater than or equal to 1000. If this is not the case, okay, what is the other choice that you have? When x is equal to 1000, first what we need to do, in the very first year, if it is less than or equal to 1000, we should go for adding it. Okay, we should go for adding it. So we have made one choice at the first year. Okay, now for the remaining y minus 1 years, for the remaining y minus 1 years, what we need to do? We should simply say x, like our answer will be, okay, let's say this is also our answer. Okay, we can simply say our answer will be something like whatever our current value of x is there, okay, it should be doubled for y minus 1 number of years, because in the first year I made a choice of adding 1000. So it will be simply uh, 2 power y minus 1 into x. That's it. Okay, very straightforward, nothing uh, complex in here. Let's go for writing the code. Okay, yeah. I'm going to do it in CBP. Let's say we have t number of test cases, and for each test case we are getting two things. What are those two things? One is x and one is y. Always choose the variables that they have given, variable names basically. mm, okay, x and y, they are integers, right? Integers. Okay, so we have two choices, that is, first let me read x and y. So simply x and y. Okay, so if x is greater than or equal to 1000, all those y number of years, like we'll go for doubling it always. So what will I do? I'll do something like answer equal to answer. Let's say in here answer equal to 0, something like this. Okay, answer equal to answer into 1000. Sorry, my bad. What will be the answer? Answer equal to x into 2 power y. Okay, but what is 2 power y? How can you write this in programming? In bit manipulation, using bit manipulation, you can write it this way. Again, if you want to use your math library, you can use it, but I'm going to choose this one. And yeah, so if x is less than 1000, for the first year, obviously we'll go for incrementing our x by 1000. Okay, so at first year I made a choice. Now for the remaining years, what I can do, because it is crossing 1000 after first year, for the remaining years I'll simply do, okay, uh, what should I say, I double it. Okay, so how many times I'm going to double it? Simply y minus 1 times. Okay, and yeah, let's go for printing this, and I hope it is going to work. If not, we'll fix it. Okay, God is great, it's working. Let's submit it. Yeah, let's move on to the next problem. Okay, let's start with the next one. A simple problem. Let's say there are two players who are playing rock, paper, and scissors. Assume like player one and player two. Let's say player two is a dumb player as of now. So what he did is, if there are n games overall, okay, he have written all the n moves that he is going to make. Okay, on a paper, let's say. Now all those n moves. So first it was rock, second it was scissors, third, let's say he chose to make scissor move again, something like paper. Okay, let's say he has chose n moves, and let's say he have written all those moves on a paper. Now this player one was able to find this paper, okay, where all the n moves are there for those n games. Okay, now this player one has to play the game along with player 2. Okay, and we need to find the maximum number of games that player 1 can win. Okay, so they are going to play the n moves, okay, or n games. Now player 1 already knows what moves player 2 is going to make. Okay, so at this step, what is the move that you are going to make so that player 1 can win? At this step, what is the move that you are going to make so that player 1 can win? Okay, so in this way, you need to find the maximum number of games that player 1 can win. And the condition that they have given in here is, obviously, if there is no condition, you can obviously make player 1 win at each and every position if you know what he is making a move at this position. Okay, the condition that they have given is no two adjacent positions, no two adjacent positions, or in no two consecutive games, you shouldn't player 1 shouldn't make the same move. Okay, I mean, if we have chose rock at this move, in the next move you cannot choose rock again. Okay, as player 1. Okay, now, yeah, let's look into the logic. That is a question. I hope the question is clear. If not, obviously you have the question in here or in CodeChef. Go through it. Okay, the agenda is the solution. Uh, okay, let's continue. So how do we go about the solution? Let's say we have some moves, something like R, P, S, S, P, or let's say P, R, P, S, something like this. Okay, if you have this sequence of moves, that will be played by player 2. And so you are player 1. You want to win the maximum number of games that is possible. If you see in here, first of all, let's try to understand rock, paper, scissors game. What is rock, paper, scissors game? So if a player chooses rock, okay, and if other player chooses paper, okay, the player who chooses paper is going to win over rock. Okay, and if you want to win on scissor, obviously you should be making a move of rock so that you can win on scissor. And in the same way, if it is paper and if you want to win on paper, okay, you have to use scissor in order to win on paper. Okay, so there is no interdependency within these three. Okay, uh, in order to win on top of this, obviously you need to choose paper. In order to win on top of this, you need to choose rock. In order to win on top of paper, you need to choose scissor. Okay, no other thing for paper. Okay, now if this is clear, let's move forward. Okay, now if these are the moves that we have, obviously if the adjacent ones, if the adjacent moves are not same, if the adjacent moves are not same, at this position, what you're going to choose in order to make player 1 win? Obviously it is paper. Okay, again the move that you're going to choose at this position will be for sure different, will be for sure different, because these two are two different moves by player 2. Obviously in order to win at this position, you can go for what is it, scissor. Okay, again if it is scissor, you can go for what is it, rock, obviously. So the moves that you're going to make at this position will also be different. Okay, whatever in here, if the adjacent ones are not same, obviously you can pick one of this, okay, whichever will help you to win that particular move, okay, or particular game. Okay, so you're going to make those moves and you're going to win them, right? So obviously if the adjacent ones are not same, these moves that you're going to make will also be different, and yeah, you will be able to win all the games. You will be able to win all the games. So what is the main logic in this? The main logic in this that we need to figure out is, when will player 1 has to make two same choices? Okay, when will player 1 has to make two same choices? If player 2 have made two same choices adjacently. Okay, again at this position, if it is scissor, on scissor, if you want to win, you have to make a move such as rock. Okay, so if the previous one is scissor, current one is scissor, obviously In order to win in both the games, you have to make rock and rock. But the thing is, rock and rock is not possible. Okay, rock, paper, rock is possible. Okay, now let's see. Let's see. The thing is, if you have a string RPS and let's say P, okay, and some P's, okay, maybe something like this, and R, P, or whatever, S, P, R, P, S, okay, something like this. So if you have these as your moves, okay, if you see all the moves that you're going to make for this input in here will be different. Okay, again, all the moves that you're going to make after this or maybe after this are are going to be different. Okay, now what about these? What about these? So in here what are the moves that you're going to make? What is the maximum number of games that you can win in this particular segment? If you see, I can win all the games here, all the games here, but in this segment, how many games I can win? It is, figure it out. Okay, and let me also give you one more example, which is RPS, PP, P, and let's say P and a P more, one more, SPRPS. Okay, if I'm going to choose this particular string, okay, now in this, how many moves are you going to win? Like, what is the maximum number of games that you're going to win? Okay, enough. Let me tell you. Obviously, the maximum number of games that you're going to win in here will be 3. Okay, and what about this? The maximum number of games that you're going to win will be 3 again. So, let's say in here, you chose something like, let's say, Caesar. Okay, obviously, this won't be Caesar. Okay, this should be Caesar again. In order to win 3 games, okay, this should be Caesar again. Instead of Caesar at this position, let's say you have chose rock or rock, paper itself. Okay, and let's say this is something like Caesar. Okay, now at this position, you cannot choose Caesar again. So obviously, in order to win 3 games, which is the maximum that you can win, you have to choose Caesar at these 3 positions. Again, in here, no matter what combination you try, choosing this position, this position, this position as Caesars, what is this problem got boiled down to? A very simple thing. So you might be having the string, okay, with adjacent characters differently, and some part of the segments can be same, okay, and others something like SP, something like SP, whatever. Okay, I'm just writing randomly PRR again. So something, few segments in here can be repetitive. So whatever segments are repetitive, so if it is a even length string, obviously how many games are we going to win? N by 2. Again, if it is a odd length string, so let's say there are string, so let's say there are 5, it is like 5 by 2, which is going to floor division, right, which is going to give you 2 plus 1. Or I can write it in a better way, that is c by 2 plus c mod 2. C mod 2 will give you 1. Okay, so I can combine these two expression as be able to understand this. If not, trace it out, you'll understand. Okay, let's go for writing the code. Okay, let's go for writing the code. Okay, what are we getting? We got something like T. Let's read T. Okay, minus minus 2. Yes. Okay. And sorry, n. This will be n. And how do we go for iterating? I'll just check I and I minus 1. Okay. I'll just check I and I minus 1. I and I minus 1. I mean, what do I mean? Let me tell you. Okay. I'll just give a bit more brief explanation for the same thing. So what I'm going to do is I'll just directly start from this position. I'll say count is equal to something like 1. Okay. Now when I'm at this position, I'll simply check. Initially, I'll initialize my count to 1. Okay. Before I start at this position. That is basically index 1, 2, 3, 4, 5, 6, so on. Okay. Now I'll simply compare I and I minus 1. Are they same? No. If they are not same, so whatever is there till now, okay, for that I have the count. Whatever is there till now, for that I have the count. Now for that, like using whatever the count that I have till now, I'll update my overall answer. My overall answer will be updated as c by 2 plus c mod 2, whatever the current count that I got. So till here counting or adding is done to my answer, that is my answer will become something like 1. Okay. Now after that I'll go to the next one, which is p. When I go to this p, I'll again update my count as 1. I'll start freshly from this position. Again, just follow, you'll understand. So when I'm at this p, again I should be counting from this period. I'll just say I and I. Okay, let's move forward. uh, I'll take a different example. Let's say we have this string. Give me 1 second. Ha. Let's say we have this string. Now, let's say I'm at this position. Okay. For this particular segment, let's count. Okay. And after that, for this one, this one, this one, this one, I'll consider each of this as different segments. This one as one more segment, one more segment, one more segment, one more segment. Okay. I'll just have to count the segments. Okay. For each and every segment in here, I'll say count by 2 plus count mod. Count by 2 plus count mod. Okay. That is what I'm going to do. Count by 2 plus count mod 2. Okay. So for each and every segment, I should basically get the count, and yeah, I should update it. So how do I go for doing it? And answer equal to something like 0, and C is equal to something like 1. I'll start from index 1. So basically I have counted it for element at index 0. Now what will I do? I'll simply start with s of I if it is equal to s of I minus 1. If these two are same, what we need to do? We should just increment the count. We should just increment the count. And if they are not same, what we need to do in that case, I and I minus 1 are not same, that means we have the answer for the previous segment. Till I minus 1, we have the answer for the previous segment. So using that, I'll simply update my overall answer. So answer plus equal to simply c by 2 plus, okay, c mod 2. I hope you understood how we are getting the c by 2 plus c mod 2. Okay. And answer should be reinitialized to 1, because from our current position again we should still continue our counting basically. Now if we are doing this, what will happen for the last segment? Okay, that means if we have all p's, or after some pr, if we have like all p's at the end, you will increment the count, because I and I minus 1 are same. Increment the count, and yeah, this will be the last iteration. You'll increment the count, but that count won't get updated to your overall answer. Now what you need to do about it, simply say answer plus equal to count by 2 plus count by 2. Okay, let me see out. Oral answer, something like this. Okay, let's run it. Okay, it's working fine. I hope it will also get submitted. Yeah, it's done. Let's move on to the next problem. All right, let's start with the next problem. A simple problem, that is, let's say there is a number something like 129. First, let's try to understand what we are going to do with a given number. So let's say if a number like 129 is given, and what you need to do is you need to perform some operations, and at the end you need to get one digit on after performing some operations on this number. The operations that you're going to perform is basically you are going to take the sum of its digits. What is the sum of this digits? 9 plus 2, which is like 11, 12. So sum will be 12. Now again on 12, okay, you need to perform the same operation until you get to one digit. So when you do this, so you'll get something like 1 plus 2, which is something like 3. So yeah, 3 is what you have reached. Okay, so 3 is a single digit. Now basically they are calling this as the origin of 129. They are calling this as origin of 129. Okay, now what they are saying is, given a value n, let's say n is something like, say, 100. From 1 to 100, from 1 to 100, so until 100, for every digit there will be some origin value, right? There will be some origin value which you understood previously. You need to take the sum of all of them. You need to take the sum of all of them from 1 to 100. If n is equal to 100, from 1 to 100 you need to take the sum of all of those origin values. All these origin values are basically integers from 1 to 9. Okay, their sum is what you need to return. Okay, now how do we go for solving this problem? Basically, if you go for writing the pattern in here, it will be very easy for you to trace it out. So for 1, it is 1 only. For a 2, it is 2 only. For a 3, because they are single digits, the origin will be 3. Okay, 4, and so on till 9. It is the same thing. When I go for a 10, can you tell me what will be the single digit that we are going to assume? 1 plus 0 will be 1, right? So 1. Okay, when I go for 11, again it is 2. When I go for 12, okay, it will be 3. So on, when I go for 18, it will be 9 again. Okay, when I go for 18, it will be 9 again. When I go for 19, what will be the sum become? 1 plus 9 will become 10. Again 10, when I again add them, say, digit by digit, 1 plus 0, it is going to give 1. So if you see, at 19 again I got 1. So on, at 27 it will again become 9. Okay, so are you able to see a pattern that is from 1 to 9 is repeating? A pattern of size 9 is what repeating. Okay, so if a number like 30 is given, and if, okay, let's take some number which they have already given, something like 12, let's say. So for 12 the output should be 51. Okay, for 12 the output should be 51. Let's say if they have given the output as 12. Okay, we know that how many chunks can be there, how many perfect chunks of size 9 can be there in n. Let's try to first find it. So if the given value is 12, obviously there can be one chunk of size 9. Okay, where it will contain all the values from 1 to 9. Okay, now remaining chunk which will be written, like remaining is 10, 11 and 12. Remaining chunk will be 10, 11 and 12. Now what is the sum of first 9 natural numbers? It is 45. Okay, sum of first natural numbers is 45. Okay, now what is the uh, sum that is contributed from these positions? So for 10 we know it is 1, for 11 it is 2, for 12 it is 3. So for the remaining three numbers, obviously it is going to be 1 plus 2 plus 3. If there were, okay, it would have been 1 plus 2 plus 3 plus 4. Okay, so it is like 45 plus whatever 6 is there, which will be 6, which is giving us 51. Okay, now in the same way, let's go for a different example. So if the value of n is something like 30, if n is 30, how many perfect chunks of size 9 can exist? Okay, so from 1 to 9, one perfect chunk. From, okay, or let's write it this way. Yeah, okay, from 1 to 9, one perfect chunk. From 10 to 18, one more perfect chunk. Okay, where the single digits will be from 1 to 9 only. Okay, those origin values will be from 1 to 9 only. Again, from 11 to, sorry, not from 11 to 19 to 27, one more for perfect chunk, and there will be a small chunk that is left. Okay, that is from 28 to 30, there will be a small chunk that will be left. Okay, now for this chunk, what will be the sum? 45. For this chunk, what will be the origin sum? 45 again. For this chunk, what will be the sum? 45. Now, how many elements are remaining? 3 elements are remaining. Obviously, 28, 28's value will be 1 only, 29's will be 2, 30's will be 3. So, what if this was something like 33, something like this? If this was 33, this chunk size would have been something like 6. So right from 28 to 33. Now in this case, you should have taken after 45 plus 45 plus 45, you should have added the sum that 1 plus 2 plus 3 plus 4 plus 5 plus 6. This is what you should be adding to 3 into 45 plus whatever the sum of first 6 natural numbers is there. Okay, so the thing is, first you need to find how many chunks that you are getting. Okay, after that, for the last remaining chunk, if a remaining chunk is there, okay, for the last remaining chunk, for the small chunk, you just have to find the sum of those many natural numbers. If there are 6 numbers in here, those many natural number sum is what you need to find. That's it. Okay, so how do we find how many numbers are there? So if n is something like say 33, okay, somehow we'll try to find 6, somehow we'll try to find 3. So if 33 is there, how can I get 3? How can I get 3? Saying there are 3 chunks of size 9, simply divided by 3. Okay, floor division in programming, it is going to give you 3. Okay, uh sorry, not by 3, by 9, my bad, by 9. Okay, if you are going to divide it by 9, obviously you are going to get the value as 3. Now basically it is like n by 9, it is going to tell you how many chunks are there. So each of this chunks value will be 45. Each of this chunks value will be 45. Okay, and what about the remaining chunk? How many values are left? How do you get this? Either you can do something like n minus n by 9, or you can simply say n mod 9. If you do n mod 9, what is 33 mod 9? 33 mod 9 is obviously 6. 33 mod 9 is obviously 6. So whatever 6 is there, you can simply do 6 into 6 plus 1 by 2, which is the first 6 digits national number sum. Okay, whatever the value that you're going to get, add it with whatever the value that you're getting from here. So this plus this is what your answer. Okay, now let's go for writing the code for the same. Okay, and if you see in here, the value of n is from ranging from 1 to 10 per 18. So for this very reason, you have to go with long in here. Something like while t minus minus, something like n. Okay, still I said long, but I'm using end. My bad. Long end. Let's say something like this. Okay, reading of n is done. After reading n, what should I do? Okay, I just have to find what is it? Number of times this will be divided. Okay, first let's also find this one. X equal to n mod 9. Okay, this value will be in between 0 to 8, obviously. Okay, and directly print the output. What will be the output? It is simply n by 9 into 45, which is the number of chunks that will be having the chunks value plus. Okay, plus what is the other value that we need to like add in here? Whatever the remaining last chunk is there, x into x plus 1 by 2. Okay, so something like this, and whatever the value that you are getting this, I'll wrap it up and let's say slash and done. Okay, let's run this. I hope everything is fine in there. Okay, it's working. Let's submit it. Got it. Okay, it's working and all good. Let's move on to the next problem. Okay, let's continue with the next problem. So let's first try to understand the problem in here. Okay, I hope you have gone through the problem already. Let's try to understand the problem. Let's say there is an array of certain size. Let's take this 2, 5, or let's take the given input as of now. Okay, the given input is something like 3, -1, 2, 4, and 5. Okay, now for this given input, what you need to do is, let's say, okay, there is an array of certain size and the size of the array is odd always. Size of the array is odd. Now every time what you have to do is you need to pick three values, any three values, pick any three values, remove all those three values. Let's say a, b, c are the values that you have picked. Now what you have to do is a plus b minus c is what you need to do. Let's say this is equal to d. Okay, so let's say this is A, this is something like C, this is something like B. Whatever may be the order. Okay, order doesn't matter for A, B, C. Whatever. Let's pick these three values. We need to remove these three values from the array and we need to perform our operation. After performing our operation, whatever D that we are going to get, we need to add it again. So that is after performing this for one time, it will be something like -1, uh, like 5, and the new D that I have got. Okay, and I have to do the same thing until I'll be reaching one single element. If you see in here, for the first time what happened, I've removed three elements, added one element. So that means overall two elements have been removed, or the size of the array got reduced by 2. Okay, again when it was 5 it became 2. As mentioned, the size of the given array will be odd. Now 2 like 5 reduced by 2 will become 3, 3 reduced by 2 will become 1. Now the thing is, whatever the size of the array that you have been given, like odd size array, every time it will be reduced by 2 by 2 by 2 by doing these operations. At some point it will reach one single element. Okay, at some point it will reach one single element. Now what you need to do is, what is the maximum achievable value at this position is what you need to find. What is the maximum achievable value uh, when you reach an array of size 1, what is the maximum achievable value that you can find? Okay, let's go to the question later. Okay, first let's try to understand the idea over here. Now how will we be able to find the answer for any given array? Okay, how do we find the answer? You might be thinking of sorting the array. Okay, like in some sense you are in the correct direction if you are thinking of sorting. Or the very first idea that you might be thinking of can be like, we'll pick the first max, second max, and the minimum in the array. First max, second max, and the minimum in the array. So when you do first max, second max minus minimum, okay, minus of -1, basically, which will be +1, overall it will be something like 9 plus 1 will be what is it, 11 or something. sorry 10. Okay, so first you'll be getting a value 10. Okay, now we will remove these three. After removing these three, you'll be having 3, 2 and 10. Okay, so again in here, if what you need to do, again you have to repeat the same thing, that is pick the next two maximum values, sorry not these two, these two next to two maximum values, 10 and 3. Like you'll take 2 as the minimum value. So from the maximum that you can achieve, okay, you'll try to remove as minimum value as possible. That's what you need to try so that you can achieve the maximum value. Okay, I hope this is making sense to you. Again, I'll try to pick the maximum values, like max and second max in this current position, and I'll try to remove it with the minimum value so that I can achieve the next max value. Okay, so if I achieve the next max value, it will be something like 11. Okay, now if you see, I have reached one single element. Done. Okay, 11 will be the answer for this given array. 11 will be the answer for this given array. If you try out any other combinations, 11 will be the maximum out of all those combinations. I'm sure of it. Okay, again, why will this yield the maximum value? Why will this yield the maximum value? If you think about this, let's just first sort this, something like minus 1 2 3 4 and 5. Okay, end of the day, you want one single element which is the maximum value achievable, right? Now if you want one single element which will be the maximum value, obviously at each and every step when you're performing this operation, you have to create one bigger value, one bigger value, one bigger value. So the expression that we have is a plus b minus c, a plus b minus c. So if I'm going to pick max and second max, okay, if I'm going to pick max and second max, can I say this is bigger than uh, like I'll be picking max, second max, and a minimum value rate. So can I say these two will be always greater than the minimum value that I'm going to pick? Yes. If that is the case, that means, let's say this is like A, this is like B, and this is this positive value plus A. Okay. Again, if there are duplicates in the array, if there are duplicates in the array, then what would be the case? All these three will be the same elements, or this entire array will contain the same elements in the worst case. Now if that is the case, this will be like 5 uh, 5 and 5. So then this and this will get cancelled out basically, and whatever is there in A will be remained. If that is not the case, B will be greater than C, B will be greater than C, and after like you'll get some value which is greater than or equal to 0, and overall value value, at least this much will be your maximum value. Okay, so what you try to do in the first step, you try to subtract this minus this, that is the max minus second max minus the minimum. Okay, so this will give you some contribution to your overall maximum value. Okay, now after getting this value, what you'll try to do? Okay, what did we achieve? If you see, we have achieved something like 2 3, and a plus b minus c is going to give you 10. Basically, a plus b minus c is going to give you 10. Okay, now what we'll try to do, we'll try to do the same thing again. It will be, your overall value will be at least 10 or more than 10. Okay, it won't get decreased. Okay, it won't get decreased if you are choosing the values this way. So what's going to happen? The overall value that we are going to get will be something like 11, something like 11. Okay, now from this observation, what can we understand? So if we have array like -1, 2, 3, 4 and 5. Okay, so if you have this array, this entire array can be seen this way. At least my maximum value will be 5. At least my maximum value will be 5. Okay, so this 5 will always be there. Okay, on top of it, some value will get added. What values will get added? Basically, this minus this. Okay, 4 minus of -1 plus. Okay, in the next step, aren't we doing 3 minus 2? Yes, we are doing 3 minus 2. So if you are having something like -1, let's say something like 1, 2, 3, let's say 4, something like 5 and 6 as your array. Okay, some random array which I have chosen 3, 3, 6, 7. Huh. If I'm choosing this array, your maximum value will be at least 6. Your maximum value will be at least 6. On top of it, some values will get added. Basically, this plus this one, this, I mean, basically 5 minus of -1 will be contributed to your maximum value. 4 minus 1 will be contributed to the maximum value in the next iteration. 3 minus 2 will be contributed to the maximum value in the next iteration. So I hope you are able to understand, right? So it is simply 6 plus 5 minus of -1 plus basically this one. Okay, plus 4 minus 1 plus 3 minus 2. This is what we'll be getting as the maximum value for this given array. Okay, even if you trace it out with all the possible combinations, that is what you are going to get. Now, from this observation, like how we are going to put it into the code. So there is one issue. Okay, if you can sort this array, and after sorting this array, like you'll do this operation, which will be a very easy operation for you, and you can say, yeah, we'll do this in one single iteration. After sorting it, you'll be getting the answer. No, that's not as simple as what you are thinking. Because, so what they're asking is, let's try to understand the format. They're giving t number of test cases, so read t test cases. Now in each test case they are going to give you two values, n and q. Okay, n and q. What is this q? I'll tell you. Okay, n is basically size of the array. So after that they are giving you an array of size n. They are giving you an array of size n. Okay, now after getting this array of size n, after reading this array of size n, let's say the array is something like 3 minus 1, 2, 4 and 5. Now they are giving three more values, okay, which is equal to this 3. So this 3, which is representing the q number of queries, is saying that I'll be getting three more values. So what are these three more values? When I say 3 for the first time, when I see this first 3, what does this represent? It will say for the first three elements, for the first three elements, whatever the operation that you have been doing to reduce the array to one single element. Okay, for the first three elements. Okay, if when it says 3 for the first three elements, what could be the answer? Okay, if it says 1, okay, do the same operation that you have done, okay, or that I have explained you for that first one element on the given array, and tell me what will be the answer. Okay, and in the same way, if it is 5, okay, do the same operation on the first 5 elements. So again, the numbers that he is going to give you in here, the values of each and every query that he is going to give you will be an odd length. So in this entire array, like, you're not going to find the answer for that entire array. Okay, what you have to do is you need to answer it for each and every odd index. You need to answer it for each and every odd index. Okay, like that odd index will be mentioned by him. For that particular odd index, you have to basically answer. Okay, if he says 3 for the first three elements, okay, what will be the answer? For the first three elements, what will be the answer? He's saying 6 as the answer for the first three elements. So for every query in here, you have to print some answer. For 3 it is 6, for 1 it is 3, for 5 it is 11. Okay. Now how are we getting this? Let's try to understand. So when it said 3, so for the first three elements, 3, 2 and minus 1, what elements you are going to pick? Like how you are going to segregate them? So obviously you will pick 2 and 3 as your B and C, or A and B, and your C will be something like minus 1. So A plus B minus of minus C. Okay, basically minus 1. Okay, which is A plus B is something like 5. 5 minus of minus 1 will give you 6. Okay, this is our first out. Okay, now in the same way, if he is going to give you 1, if he is going to give you 1, so obviously if there is only one single element, 3 will be the answer. Okay, for that particular length. Now if he is going to give you this particular array, that is an array of size 5 in this case. Okay, let's say from whatever we understood previously, if you're going to sort the array, something like this. Now for that, what will be the answer? Obviously you're going to segregate this something like this. So 5 will be always be there. 4 minus of minus 1 plus 3 minus 2. Okay, overall answer will be 5 plus 4 minus of minus 1 will be 4, minus of minus 1 will be plus 5 again plus 2 minus 3. This is what you are going to do. What will be the overall value? 5 plus 5 plus 1, which is 11. Okay, which is the third value that we need to print. Okay, I hope this is clear. The input and output is clear to you. This is the maximum value achievable. Now let's try to understand the same thing. uh, that is, give me 1 second. So this part, okay, that is segregating, or okay, I'll come to this in 1 minute. The thing is, in here, the queries or the test cases size, all of that, what they have mentioned is size of the array can be 1 from and size of the array can be from 2 to 10 power 5, sorry, 1 to 10 power 5. Okay, and size of the queries will be in between 1 to 10 power 5, something like this. And value of each query, okay, like value of each q of I will be in between 1 to n. Okay, so they'll give you one index, one size, one particular segment, and this value will be always odd. Okay, this value will be always odd. That's what they are saying. For that particular segment, you need to basically answer. So your query size can be, basically it can be 1, it can be 3, it can be 5, it can be 7, so on till size of the array, which is n. Now for each and every query, you need to basically answer it. For each and every query, you need to basically answer it. Okay. Now what can be a simple solution but that we'll think of? Okay. Whatever may be the t number of test cases, we'll loop over it. Now for every test case, what we'll try to do? Okay. We'll read the array. Reading the array, let's not consider any time complexity. We'll iterate through every query. So there are q number of queries. Like there are 10 power 5 queries basically. For every query in here, what you try to do, you basically sort the array. Sorting the array optimal time is something like n log n. Okay. Now after sorting the array, you have to do that math calculation, which is going to take n time. Okay, so overall time complexity, if you see, it is already crossing more than 10 power 10, okay, or 10 power 12, which is going to give you TLE, which is going to give you TLE. Again, how are we calculating this? If you are a member of Smart Interviews, you'll know it. I mean, if you are a student of Smart Interviews, I hope you are able to understand it completely. Again, even if you're not able to understand this, not a problem. Okay, let's get to the optimal solution. Okay. Now the thing is, we need to answer this for each and every index. Again, for every query, if you're going to find the answer separately, for every query, if you're going to find the answer separately, uh, it will obviously take q into n time into t. Okay, q into n into t, again, which is going to give you TLE. Now, what you need to do? What you need to do is you need to compute the answer, or basically pre-compute the answer for the n elements. So how many, whatever maybe the odd indices that you have, okay, let's mark these odd indexes. This one, maybe this one, maybe this one. Okay, for each and every odd index in here, you need to calculate the answer in one go. Okay, while iterating through the array for one time, you have to calculate the answer for each and every odd index position. For each and every odd index position, after calculating this, let's say you have stored this in some answer array. Now, if they give you an index something like 3, if they give you an index something like 3, you'll directly access that index 3 or index 2. Okay, because if they mention 3, they are basically mentioning uh, 1 based indexing. Now, if you converted it to 0 based indexing, obviously it will be 1 lesser than that. So you will go for even based indexes. So whenever you are at an even index, for that particular index, whatever the value have like is there, you'll directly return that value. Whatever value is stored, you'll directly return that value. I hope you're able to understand what I was saying. The thing is, first we are going to calculate this answer array. Using this given array, we are going to calculate this answer array. Now, after calculating this answer array, uh, for every query, okay, so it will be something like, in each test case, first we'll populate the answer array using the by iterating through the array by one time. Maybe some in some n or n log n time, we will try to populate this answer array. Now, after that, we'll iterate through our q number of queries. After that, we'll iterate through our q number of queries. For each query, we'll just access the index in our answer and we'll try to print it. Okay, let's try to understand how. Now, the thing is, again, not at all complex. Try to focus more. When the query was when the query was 5, okay, when the query was 5, that means you need to find the answer for these first 5 elements. When the query is 3, that means you need to find the answer for the first three elements. Okay, it is not like you'll sort the entire array for one time and you'll be getting the answer. No, if you sort the entire array for one time, okay, all these elements positions will be changed. Again, answer for these first three elements, like the first three elements will might be something different from what your expected answer. Okay, if you're going to calculate it. So for this very reason, what we need to do, if you see, if you see, end of the day, let's say if it was first 5 elements, it is like -1 2 3 4 5. Okay, so you are trying to have this with you, this minus this minus this. Can I convert the same expression, like whatever the sum that I'll be getting from this part, I'll try to subtract it from this part. Okay, no confusions. Okay, this sum minus this sum. Okay, let's say this is your B, this is your A, okay, and this is your C. Okay, subtract this part sum from this part sum and add plus A. or assume this entire segment as one thing, okay, because a plus b, okay, assume this entire thing, simply subtract c from that entire thing. Even if you're going to do this, you'll be getting the same answer, no? So if you see, 9 plus 3 is something like 12. 12 minus 1 is something like 11, which is our expected answer, okay, which is our expected answer. Okay, try to understand this. Using this itself, using this idea, we are going to go for the solution. Again, the solution that we are going to use, or the algorithm that we are going to use, is a famous one. Okay. um, Again, in order to understand this, median, I'm bad at spelling, so please ignore. Median of two sorted arrays. Okay. So the problem is median of two sorted arrays. Uh, Go and check the solution for this problem, or try solving it on your own before we continue. Again, if you already know it, then great. We can go ahead together. Still, I'll try to make you understand what is our algorithm completely. Okay. So I hope you were able to understand it. Our problem simply boils down to, if the value of n, like, query is something like 3. So the first three elements in our array was 3 minus 1 2. Okay, if you can say, like, let's say you have the left part and right part. Left part is basically minus 1, 2 3 will be your right part. Okay, so if you can segregate this way, what is the sum of this? 5. Okay, 5 minus of minus 1 will be 6. 6 is your answer. Okay, 6 is your answer. But at any point in time, you want the left part sum and right part sum. If you have the right part sum and left part sum at each and every odd index, if you have the left part sum and right part sum at each and every odd index, uh, that means you can have the answer at each and every odd index. Okay, let's see how we'll go for it. So let's say this is the given array that we have, and for this given array, let's try to find the answer with our algorithm. So again, obviously, for the first element, the answer is going to be 4. We know that much. Okay, after all this discussion, that much should be clear. Now we need to store some answer at this given position in our answer array. One more at this position, one more at this position. Okay, now how do we go for calculating it? What I'll try to do is, I'll try to take two buckets. I'll try to take two buckets. So one is, let's say, left bucket, one is, let's say, right bucket. Again, these are two data structures which we'll see within some time. Okay, what are those data structures? So first I'll try to insert first two elements. Okay, that is 4 and 2. Okay, basically 2 and 4. What I'm going to have in the left part, I'm going to have all the elements on the left part. Okay, so after segregation, so when I had these 5 elements, so after segregation, if you see what elements I'm having on the left part and what elements I'm having on the right part, I'm having all the first half after sorting them. What will be the first half elements that I'll be having? Whatever those first half elements will be there, they'll be in the left half, and whatever the second half elements will be there, they'll be in the second half. Okay, so I just have to separate these two parts. Okay, I don't want to sort the array. I don't want to do any sorting, but I want to separate them. Somehow I want to separate them, and somehow I want to maintain their sum. Okay, now how do I separate them? Basically, I'm taking two data structures. Okay, At any point in time, okay, I'm going to do a traversal from left to right. Okay, for the very first time, I've inserted two elements. That's it. From here, I'm going to do my traversal. I'll go element by element, and what I'm trying to have is till here, till here. Okay, if I have traversed till here, I'll try to segregate the left part element and right part elements. So if it is like 1 to 4, if it is like 1 to 4, what elements I should be having on the left side? I should be having in on the left side I should be having only one. On the right side I should be having 2, 4. Okay. I mean, for that particular range, I'm considering the sorted thing for that particular range. So if it is sorted, what should I be having on the left part? What should I be having on the right part? Okay. In the same way, if I have explored till here, if I have explored till here, okay, the elements are something like 1 to 4, 8, 6, and 8. So if this is the overall segment that I'll have, then sorry, first two elements. So that is 1 and 2 should be here, and 4, 6, 8 should be on the right side. 4, 6, 8 should be on the right side. Okay. That is what is going to give you the maximum value for that particular five elements. Okay, that is what is going to give you the maximum value. Now, when I go till this 3, I want to segregate this way. That is 1 second. My bad. I hope you are able to understand it. So when I go till 3, overall sorted array will be 1, 2, 3, 4, 5, 6, 8. 1, 2, 3. Okay. Now first three elements will be in here, and all the remaining four elements 4, 5, 6, 8 will be on the right part. This minus this is what going to give you the answer. Okay. If this is clear, I'm just imposing two more rules. The two more rules are, at any point in time, right size will be greater than or equal to left one. Right size will be greater than or equal to left one, and I want left minus right length of the sizes of left minus right should always be less than or equal to 1. Size of right minus left should always be less than or equal to 1. Size, okay, the difference between the size should be less than or equal to 1. Either the number of elements in here and in here should be same, or the number of elements in here should be 1 less than the number of elements that I should be having on the right part. Okay, so I'll try to maintain this rule. I'll try to maintain this rule when I'm traversing on this array, and whenever I'm reaching an odd index, I'll be having my answer. I'll store that answer and I'll be moving forward. Let's see how. Okay, let's see how. So let's write the indexes as of now. Index 0, 1, 2, 3, 4, 5, and 6. I hope you are able to identify the odd positions. So this one, this one, this one, and this one. So for all those positions, we need to basically answer. So as I said before, for the first position, we know what will be the answer. We stored the answer. Okay, it's fine. Now let's go to the second element. When I go to the second element, uh, sorry, not second element. Let's say we have element 2 on the left side, element 4 on the right side. Just try to understand from now on. Okay, first elements have been inserted on those into those two buckets. Now let's start from this particular position. Okay, index 2. Now from this position, I will try to insert in certain way. What is that way? Okay, try to understand. After certain point, you'll understand why we are doing this way. Whenever I'm at a even position, whenever I'm at a even position, then that means I need to basically store some answer. That means I should basically store some answer. So whenever I'm at an even position, what I'll try to do is I'll try to insert it into I'll try to insert it into the right part or right bucket. So I have inserted in the right bucket. So after inserting in the right bucket, okay, what will I do? I won't just stop after inserting. I won't just continue after inserting. What I'll try to do is I'll try to find the minimum from the left part. What is the minimum from the left? Sorry, maximum from the left part. What is the maximum from the left part? Maximum element in the left part till now is only 2. Okay, so maximum is 2. Minimum in the right part. What is the minimum in the right part? Minimum in the right part is 1. Minimum in the right part is 1. So if maximum in the left part is greater than minimum in the right part, I'll just swap them if they are in this order. If 2 is greater than 1, I'll just swap them. So this will be 1, this will be 2. That's it. Okay. So if max in left is greater than min in right, okay, swap swap L and R in two buckets. Okay, just this much is sufficient. This much is sufficient. Okay, we don't have to do anything else. This will always be maintained. Okay, this rule will always be maintained. If you just do this, this rule will always be maintained. Let's try to understand. Again, we'll continue. When I'm at an odd index, I'll simply insert it into the left bucket. I'll simply insert it into the left bucket. Now after inserting into the left bucket, again what will I check? Again I'll check for the same condition, which is whenever I'm going to insert some element, first I'll try to insert based upon odd or even index. If it is even index, I'll insert it into the right part. If it is odd index, I'll insert it into the left part. After inserting, okay, I'll check for one condition. What is that one condition? Maximum in the left. What is the maximum in the left? 8. Okay. If it is greater than minimum in the right, minimum in the right is 2. Is it following the condition? Yes, it is following the condition. Then swap them. Then swap them. 2 and 8. Okay. Now, okay, I just missed one point which I'll come back. Okay. From this, I'll just move forward to the next element. From this, I'll move forward to the next element. Okay. When I move forward to element something like 6. Now, again, what type of index I'm at? I'm at 10 even index, or basically I'm at a position where I have to calculate some answer. Now, whenever I'm at this position, I'll directly insert my current value into my right part. After inserting it into right part, okay, either that element will go to left part or the right part. After inserting it, what we are doing, we are trying to find, okay, uh, like we are trying to check maximum in the left part if it is greater than minimum in the right part. No, it is not greater than minimum in the right part. So what we'll do, we won't swap them, so whatever is there, we'll let it be that way itself. And what we'll do, whatever may be the sum that we are having, sum of elements that we are having in this, from we'll just subtract it with whatever the sum of elements that we are having in here. That will be the value that I'm going to store at this position. It will be the same even at this position. When we were at this particular position, okay, if you remember, we had something like 1 and 1 second, what we had, 1 and 2 4. Okay, even at this position we would have done the same thing, that is sum that is there on the right part minus sum that is there on the left part. Whatever that you are going to get, you are going to store it at this position. Okay, by the time we have reached 6, what we had till now, we had something like 4 8 6 on the right part and 1 and 2 on the left part. Okay, still if you continue, whenever you reach an odd index, what is the first thing that you have to do? You just have to put it into the left part. Put it into the left part. After putting it into the left part, move forward. Okay, sorry, not move forward, you need to check for the condition. What is the condition? Max on the left, is it greater than min on the right? Max on the left, is it greater than min on the right? Yes, they are greater than. So just swap them. Just swap them. Just move forward. When you are at 3, like last position, like if it is an even index, obviously insert it. But after inserting any element, either from the left or right, again you should check max in here and min in here. If they are not following the order, like if they are following the order, swap them basically. Now if you see, by the time we reach the last element, isn't it these the arrays that we want? Yes, whenever we are reaching an even index, okay, we were able to achieve the sorted left part, the sorted right part. Okay, and if we are just trying to swap, the maximum and from the left with minimum from the right after every insert. After every insert. By just doing that, if you see, we were able to achieve the sorted left part and the sorted right part, okay, or sorted right half, okay. Now I just want to take the difference in both of these sums. All right. Now this is the overall discussion. When we go for look like writing the code, you will be able to understand whole of it. But can you tell me what are these data structures? Okay. So you need a data structure which should help you. Okay. In the left part, we are trying to remove the maximum value every time. Okay. And like we should know what is the maximum value at any point in time, and we should be able to remove that maximum. And in here, what about right part? We are only caring about the minimum value in this entire range. Okay, by just considering the maximum from the left or minimum from the right, by just swapping them, how are we able to achieve this sorted part, sorted left part and sorted right part? Very, 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 very simple. That is, we are starting with initially we are starting with one element. Okay, whenever we are going to insert one more element, whenever we are going to insert one more element, after inserting, first we are inserting. After inserting, we are checking if the minimum maximum in the left part. Okay. Here let's say when you had one element. Okay. When you had one element, we are checking is the maximum in the sorry, when we reach this particular index, we'll directly insert it here. After inserting one new element, we are checking for the condition. Based upon our condition, what how will it help us? It will help us in sorting these parts at this given moment. So if you see, first these three elements have been sorted. First, these three elements have been sorted, like left part and right part. Whenever you go for inserting one more element, again at that moment, only you'll care about min and max because that's what matters at this given point, and you will swap them. Okay, just think about it, give it a thought. 2 minutes will be more than sufficient to understand this entire idea. Okay, let's go for writing the code. Okay. Okay, I hope this is the problem. Minus minus. Okay, we need to read an a. Okay, int array of size and not k. I guess it should be q. Okay, first we'll actually read n and q, and let's say something like int I equal to 0, I less than, and I plus plus c array of I. I've read the array. Okay. Now first let's try to find the answer. Okay, I'll declare an answer array of size n. Okay. For all the odd positions, we'll try to find the answer. We know that answer of 0 is equal to array of 0. Okay. Now, as said before, we need two heaps, min heap and max heap. Let's ask for it. Uh, Max heap, cpp, uh, basically this one. Okay. So this max heap will be our right part. Okay. Priority queue. I hope this will be max heap, and where is min heap? Okay. We'll just write it by ourselves. Okay. Okay. Messed up. Let's write it by ourselves. My bad. Sorry for wasting your time. So let's say this is like So we need min heap for the right part. Let's say priority q2 and priority queue of type, and we need it for the left part. Okay, left part, let's say pq1. Okay, now what we'll do, we'll iterate through each and every element in the array, something like that, and try to understand the code. Okay, if you are able to understand the idea, that much is very much sufficient. After that, you should be able to code it up by yourself. Okay, now as said before, if we are at any given odd index, okay, or even index, let's go for first even index. If we are at a even index, what we need to do, should we add this to p1 or p2? If it is a even index, so we need to add it to p2. p2 dot push, I guess, uh, array of I. Okay, and if this is not the case, if it is a odd index, which it should be put to uh, p1. Okay, now inserting to one of the array is done. Inserting to one of the priority queue is done. After inserting, what we need to do? The after we have crossed first two elements. Okay, after we have crossed first two elements, we should start swapping the um, like we can basically swap the elements from periodic 1 to periodic q2 or 2 to 1. So we can say if I is greater than something like 1. Okay, so for the first two elements, it will get inserted like index 0 and index 1. From index 2, this is what is going to happen. From index 2, what we want? We'll simply check. Okay, let's say p1 and p2. p1 equal to pq1 dot top, which is the maximum value in the left side. p2 is equal to p2, sorry, pq2 uh, dot top again. Uh, if p1 is greater than p2, what we need to do? Any guess? Basically, we need to swap them. Okay, swap the p1 and p2. Okay, so let's swap them. Like first I need to pop them. So I'll pop it from p1 and I'll also pop it from p2. p2 dot pop. Okay, so popping is done from both of it. Basically, I need to add p1 dot push of p2. This is what swapping mean, and p2 dot push of p1. Okay, now swapping is also done. We are done with swapping. What is the only thing? Okay, whenever we are at a even position, we need to calculate our answer. Okay, basically answer of I. We need to store something in our answer. Now what do we store in our answer? Simply uh, let's take two variables, left sum and right sum. How these two variables are going to help us? Very simple. Whatever is getting pushed to the left part, which is pq1, whenever I'm adding some element into pq1, I'll just increment it or add it to ls of I, and whenever I'm pushing something into right part, I'll just add this to rs. Okay, array of I, something like this. Now whatever has been pushed, I should basically, okay, even in here, if you see data is getting swapped between ls and rs, no? So if you pop from even, that means it should be subtracted from ls. So ls minus equal to what should be subtracted? Yes, from p1, what did we remove? Not from p1, this should be pq1, my bad. pq2, pq1, and pq2. Okay. So basically, what should be subtracted from here? So pq1 dot pop, then we should be like subtracting p1, and what should be subtracted from here? R is minus equal to p2. Okay, and ls is equal to p2 in here, rs is equal to p1 in here. That's it. Since we are pushing it to left one, adding it to ls. Since we are pushing it to right one, adding it to rs. Okay. Now whenever we are at a even index, what we need to do, we just have to calculate our answer. What is our answer? Simply ls minus rs. Okay. Now calculating our answer at each and every odd index is done. Now since we are done with calculating the answer at each and every odd index, okay, what we need to do? We need to iterate upon all the remaining queries. Something like q minus minus. In each query we have one value which is something like x or something, seen x, okay, or a, whatever it is. What we have to do? We just have to access the element in the array. Okay, how do we go for printing them? Okay, separated by space. So array of, not array of, it is answer of x. Is it x? No, x minus 1. Because x is 1 based indexing, we have to go for 0 based indexing. X minus 1, and yeah, this case will be sufficient. And what else? A new line will be printed. Okay, let's run for this. I hope everything is fine. I don't want to see any errors. Okay, no errors. Great. It worked fine. Again, will it get submitted? I don't think so. Yes. Why? Why are we getting wrong answer? Because if you see, the values that we are having in the array are like 1 to 10 power 9. So if you keep on adding it to ls or rs, it will go to the range. So make this as long and even the size of the answer array, because we are storing our answer in the answer array. Yeah, so these two, if you declare it as long, that much should be sufficient. Let's give a run first and a submit. All right, done. Okay, thank you everyone. Great. Have a nice day.